Do you know why buildings leak? Or do you want to know how to design buildings to avoid leaks? Well, after dedicating more than 10 hours studying various online courses, I'm excited to share with you my key takeaways. I linked below to the various online courses that I've studied. This video is not intended to be a complete summary of all these online courses. If you'd like to have a deep dive into this subject, I'd highly recommend you take these courses in full. And with that, let's get started. The first point that we need to cover is that there are two approaches to waterproofing: the perfect barrier system and the drain system. The perfect barrier is a high-risk approach and is most likely to fail compared to a drain system. In a perfect barrier system, an exposed face or concealed membrane layer is relied on to provide 100% of the protection. These systems have to withstand a number of constant pressures, such as UV rays, hot and cold weather, and building elements that may move, shift, contract, and expand over time. This perfect barrier needs to maintain continuous defense over its life, which is asking for a lot. In this example of a balcony section detail, the concrete slab has no floors to drainage, hence the membrane is asking to withstand constant submersion. This thin membrane will eventually deteriorate and allow water ingress into the building. The most successful assemblies are found in designs based on the drain system. The drain system assumes that water will inevitably get past the first layer of protection, but it will then redirect and drain away water through a combination of subsequent layers. In this example of a wall section detail, the brick is the first line of protection. Any water that gets past the brick wall is drained through the cavity and through the flashing. And in another example of this balcony floor slab section, the first line of protection is at the pavers, which are propped up above the concrete slabs, leaving a cavity. This protects the membrane from the weather. The slab, which is poured with a fall on it, collects and drains the water into an outlet. For a successful drain systems, there are three principles that you have to follow: let it flow, let it move, and let it work. Let it flow is about using gravity to create flow paths to drain away water. Shed water and not let it build up, just like the two examples that I just showed you. You also have to anticipate how buildings move, sag, deflect over time, because this will affect how you collect, redirect, and drain water away. In this example of a balcony floor slab section, the concrete slab deflects over time. This changes the direction of the fall for the concrete slab, hence altering the ability of the balcony to fully drain any water it collects. Engineers are able to create a deflection contour plan of your concrete slab to help determine where your slab will deflect or sag. This will then help you determine where to put your outlets. In this example, you can see that the areas near the walls and the columns have less amount of sagging. The sagging seems to happen in the areas away from the columns and the walls. This leads me to my second principle: let it move. This is about anticipating the differential movement between elements, which often create cracks that lead to leaks. Building materials respond to temperature, moisture, and various loads in very different ways. Good design anticipates where building movement is likely to occur, and then make necessary allowances to shed water away from danger and then drain the water away. Place construction joints out of trouble. Try to keep them undercover or in internal areas if possible. Avoid putting them in balconies, through bathrooms, under planter boxes, or underwater features. Where possible, try to create adjacent hobs at joints and have the slabs fall away to drainage. So in this example, you can see a section of a concrete slab with pavers sitting on top of the pedestal. There is a construction joint in the middle of the concrete slab. There are hobs at where the joints are, and the concrete falls in the direction away from the joint. You have to be careful with waterproofing membranes that try to bridge joints, because most membranes are not capable of bridging movement joints that create large gaps. That's why there is an additional capping to cover the joint above. Be sure to fix it on one side only to allow movement. The next principle is to let it work. It's about buildability, ensuring there is enough tolerance built into the design to give the best chance of the building being constructed without errors. Most workmanship related leaks occur due to a complex design and geometry, leading to inevitable errors. Good drainage systems recognize that each layer may be installed imperfectly, but in combination with other layers, these imperfections will not lead to a failure to the overall system. For example, the Australian standards may ask for a 1 to 100 floor on your floor slabs, but you should ask for 1 in 80. This is to account for workmanship errors. The Australian standards are minimum standards, and they're not always the best practice. Integral concrete hobs and integral floors on concrete slabs are always the first preference. This means they are poured at the same time rather than using screed to achieve the floors, or a steel channel filled with water to create a hob. Now before I proceed, I need to put out a disclaimer. While I think I'm a pretty good architect, I'm not your architect. I can't give you specific advice for your specific situation. Please consult your local architect or consultant to see what you need to do. I'm simply sharing what I've learned. To see a full disclaimer, please see the text below. Okay, the next area that we need to cover is water shedding principles for below ground structures, basements. These areas are most likely to have leaks. If you'd like to see me talk about that, click here to see my next video. And if you would like a free PDF summarizing this video with all my sketches, check out my newsletter below.